Hello everybody, my name is Halo. Welcome to this video series where we're solving Codeforces problems in Python. We are doing the A to OJ ladder, and in this video we're doing problem 272A, which is called Dima and friends. Let's go ahead and see how to solve this problem. Let's read through this problem once. Dima and his friends have been playing hide and seek at Dima's place all night. As a result, Dima's place got messy. In the morning, they decided they need to clean the place. To decide who would clean the apartment, the friends wanted to play a counting out game. First, all guys stand in a circle and then stand in a circle. There is also something important, and then each of them shows some number of fingers on one hand. So the numbers are 1 to 5 because we have 5 fingers, okay? And the boys count in a circle starting from Dima, the number of people respective to the total number of fingers shown. The question is quite simple. They're saying Dima knows how many fingers each of his friends will show during the counting out. Let's say there are 3 friends here and Dima. So this is friend A, friend B, friend C. So Dima knows how much friend A shows, how much friend B shows, how much friend C shows. Dima needs to find out what is the number of ways he can show his fingers so that he does not have to clean the house. For example, there are totally 4 people over here, and let's say A is showing 4 fingers, B is showing 3 fingers, and C is showing 2 fingers. Okay, so there's totally 9 fingers to be shown. See, since everything starts with Dima, right? So 1, 2, 3, 4, 5. Fifth time will be with Dima. 1, 6, 7, 8, 9. 9 will be with again Dima. 10, 11, 12, 13. 13 will again be with Dima. Okay. So similarly, 17 will also be Dima's turn. So in these particular numbers, Dima will be the person who is asked to clean. You can see this 5 case is not possible, and this 9 case is also not possible because Dima has to show some amount of fingers, and the 17 case is also not possible because right now the total is 9. If Dima shows all 5 of his fingers, the total will become 14. Correct? So this 13 case is the only one possible, and Dima can show totally how many fingers? 5 fingers. So there's total 5 ways Dima can show his fingers. He can show the count 1, so that will be 9 plus 1, or 9 plus 2, or 9 plus 3, or 9 plus 4. Or 9 plus 5. So the count will be 10, 11, 12, 13 and 14. Okay. Now 13 is not available. Okay. He cannot do this. So he cannot show his fingers in a way that he cannot show 4 fingers, or else he will get the turn. If he shows either 1 finger, 2 finger, 3 finger or 5 fingers, in that particular case, he will not get the turn. So he doesn't have to clean the house. So the answer to this particular case will be 4. He can show his fingers in 4 ways. Okay. Let's work out one of these examples so that you guys can cross-validate the answers and kind of understand things a little bit better. Let's take second case. Also, the input is given in such a way. It's given the number of n. That n is actually the number of friends, which not inclusive of Dima. So the total number of people will be given by n plus 1. 1 is Dima himself. Let's take this case because both of these cases are boring. There's only one person there. So in the case number 2, there are 2 friends, okay, and Dima. Friend number 1 is showing 3 fingers. This is second line is the number of fingers each friend shows. There will be a list of space separated integers. And friend number 2 is showing 5 fingers. So total finger count is 8. Dima can show totally 5 finger varieties. He can show 8 plus 1, 9, 8 plus 2, 10, 8 plus 3, 11, or 8 plus 4, 12, finally 8 plus 5, 30. So these are the number of ways Dima can show his fingers to kind of get the total count. Now they want to find out in how many of these ways thus Dima does not have to clean. See, this assume Dima is starting because that's what the question says tells us. We say 1, 2, 3, 4. So 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, these are all the numbers that Dima will be got. And how do you determine this particular value? It's very, very simple. Okay, you start with 1 because obviously Dima is the first guy. Then you just keep increasing that by n plus 1, the number of people, because the circle after n times it comes back to you, right? So that n is including yourself, so that will be n plus 1 here, not n, because n in the question is just non-inclusive of Dima. When you include Dima, it will become n plus 1. So that's how you find this particular value. So 4, 7, 10, 13, something like that. In order to find out, one thing you can keep in mind here, in all of these particular values, okay, in order to determine whether Dima will get caught or not, we can simply go ahead and do this particular, let's say this value is a, okay, a percentage this n plus 1. If this value is equal to 1, that means Dima will be clean. I make this assumption here, and this is true because this is how the arithmetic progression looks like for us. So every n plus 1 times things keep repeating, right? So if every n plus 1 times things keep repeating, that means that if you do this modulo operator with that n plus 1, you will always keep getting the same values. For example, in this particular case, let's say it's 0, 1 and 3 people are there, okay? Now, tell me, if you do this percentage operator of 3, what are the possible values you can get? You can get 0, 1 and 2. This operator is called the modulo operator. It will give you the remainder of any number divided by this particular value, which is 3 here. Any number divided by 3 will either give you 0, 1 or 2. We don't want 1 because that is Dima's thing, okay? And in all of these cases, see, if this is 4 percentage 3, it will give you 1. And 7 percentage 3 will also give you 1. 10 percentage 3 will also give you 1. 13 percentage 3 will also give you 1. So in either case, if this value right here is equal to 1, in that case, Dima will have to do the work. Has to, okay? So we have to find out what are the cases in which this is not true and then add all of that and print as the answer. In this particular case, if we go from, see, what are the possible values? This is what? This is sum of what list? This list, correct? We have a list of space separated integers. You sum all of them, you get the total number of fingers. You start with the value next to it because Dima has to at least show one finger, right? So 8 plus 1. We will start with 9. And then when do we stop? See, when he shows 5 fingers, it will be 13, correct? So we have to iterate through 9 to 13, but inclusive of 13. So if we are doing a for loop will not include the last element. So we'll do for I in range 9 to 14, which is nothing but 9 plus 5, not inclusive that 9 plus 5. So it will include values from 9 to 13. So you do for loop for all of that and then use this formula right here. See, for instance, let's just work this out, how that looks like. See, 9 percentage, what is n plus 1? N plus 1 is 3. That will give you 0. That means Dima does not have to do the work. Then 10 percentage 3, that will give you 1. So Dima has to do the work. Then what do? We do 11 percentage 3. That will give you 2 again. So 2 also Dima does not have to do the work. So in this case, yes, Dima does not have to do the work. In this case, Dima does not have to do the work. In 12, again, Dima does not have to do the work because 12 percentage 3 will be 0. In 13, Dima has to do the work because 13 percentage 3 is equal to 1. So what is the total number of tick marks here, or the number of cases where this particular value or this particular is not equal to 1? That will be 3. That's why the answer is 3 over here. Okay, this is what we're trying to code here. I hope you're able to understand how we're solving this problem. If you did, go ahead, try to code this for yourself. If not, stick around for the code. Right. So let's go ahead and take int of input as n. Yes. Then we'll take the total number of people. See, total number of people will be given by that number plus Dima, right? So total will be n plus 1, including Dima. Okay, then what do we need to do? We need to take a list of space separated integers, correct? So list of map of int comma input dot r strip dot split. Yes, we're taking this in a list of space separated integers. Now we need to find out what is the current finger count. Current finger count excluding Dima. Okay, so that will be given by the sum of this list, and Python has an inbuilt function. So let's just call this cur. Okay. And we can say this will be sum of this particular list. This will give you the current number of fingers. So Dima can show, see, let's also say the answer counter because we need to include every time that number of ways, and we can just call this number of ways. So that will be the answer, and there will be something that, see, okay. Then Dima has 1 to 5 fingers, correct? So he can show the total values, the total number of fingers will go from cur plus 1 to cur plus 5 because Dima has 1 to 5 fingers. You guys are able to understand up to this, right? So what we'll do a for loop from this value to this value. Okay, or we can also do a for loop from 1 to 5 and this include this particular plus in the loop itself. So how that will look like is we can do for I in range 1 to 6. because we need to include this plus 5 condition also. So we will do 1 because this 6 will not be included. So in this particular case, it will be 1, 2, 3, 4, 5, right? So that's why we're doing this plus 1 on top of that, because we need to include this also. Include this also, okay? Then what we'll do, we need to go for this particular condition, right? So we have to do this cur plus. So if the number of fingers is nothing but cur plus that particular value, i.e., we check if this percentage total value is not equal to 1. In that particular case where Dima doesn't have to clean. Okay. In that particular case, we can just go ahead and increase the answer by 1. And that's it, guys. So finally, you can go ahead and print this answer as well. Let me just run this code. You can see all the test cases have passed. Let me just go ahead and submit this code as well so that you know it works. I hope you're able to understand how we're approaching this problem. Maybe the solution was a bit lengthy for you. So as you can see, the solution got accepted. I hope you're able to understand how we're approaching this problem. It's a very, very simple problem. But yeah, maybe the explanation went on a bit too long. But yeah, that's it, guys. Thank you so much for watching this video. If this video helped you, hit that like button and see you in another video. Until then, bye.